talk to you about Xamarin and Azure and how you can connect them together. I think everyone feels a little bit spread out as well. Well, isolation points as well. Very mobile. Nice to see. So how many of you are doing Xamarin work now? One hand for Xamarin. How many are doing Azure work? Keep it, maybe the other hand as well. So some of you doing both, most of you doing Xamarin. Who's not doing any Azure or mobile work at the moment? Just kind of want to see what you can do. Okay, get a good sense of the room. All right, so we're going to talk about how we can build mobile applications on the Azure platform. A little bit of a background. I've been developing mobile applications for a long time. I actually started when WAP was still a thing. And even if I go back about 5 years ago, I remember building a mobile app, and I actually had to create a lot of the infrastructure myself. I had to write a bunch of web services, had to test those web services, I had to make sure I had connectivity, I had to create authentication processes for that app in order to log in. And I had to go through this cycle that would often take me normally somewhere between 2 and 8 weeks, just depending on the size and complexity of the level of the project. And that was just pain, and I had to do that nearly on every project. And it felt like filling out forms in triplicate. I think everyone has those kinds of moments when they're developing applications that it feels like that. Now, with Azure, I was actually able to create what I would have done 5 years ago in pretty much an hour. In a lot of those cases. So I've found that using Azure has helped my applications that have needed some server-side logic or server-side capability in a way that I never had. We're really building on what has come before. All right. So for those of you who are unfamiliar with Azure, I guess I think most of you have been at plenty of sessions around it, but Azure is basically a service platform as a service offering that we can use. In the Xamarin space, there's a mobile application service that we can use that allows us to connect into a lot of existing infrastructure. There's other infrastructure pieces that you can connect into as well, like web apps, mobile apps, API, logic apps, and a range of others. The one that we're interested in for today's session is the mobile app, where we'll look at doing things like storing data in the cloud, using push notifications, authentications, and a range of other services. Now, there's a range of capabilities on the mobile side that you can use, and it really comes down to these 3 main categories. These tend to be the fundamentals of most mobile apps, where you've got data. You need to store some information somewhere in the cloud. You might be using something like a SQL Server backend that you'll use with Azure. You might be using table storage, which is nice and fast, fairly cheap as well, to store key value style data. There's DocumentDB, which is not on that graph, which is a newer entry. There's been some great sessions on DocumentDB at the conference. And also blob storage as well. So if you will need to store files of any type, things like images tend to fall into that category. You've also got authorization, things like Facebook authorization. Most consumer-based apps will have that. You might be authenticating through things like LinkedIn or Twitter. On the enterprise side, you might be authenticating against Active Directory. And there's a fairly consistent API, or there is a consistent API that allows you to connect into that. And lastly, down the bottom, you've got push notifications, which is a real delight to stand in. And we're going to go through these main points here on the right. On the left-hand side, we're going to be using the Xamarin SDK or the client SDK for Azure Mobile Services to connect in, but you might be developing on other platforms as well. There are other client libraries that you can connect into as well. Awesome. Now, what I find is when I'm working with Azure, I normally go through 3 steps. The first step is to set up the server side. The second step is to set up the client side. And you have to set up the server side in order to connect into it from your mobile clients. So this is the first point of call. And there's two ways you'll typically do it. One, you'll set up using Node.js, which is a JavaScript-based framework. It's very effective. Lots of people are using it. Most of us who are .NET developers tend to use the ASP.NET model. Who's using Node.js at the moment? No one? Who's using .NET? Yeah, almost everyone, yeah. That's what I find as well. And Node.js is simple if you're going from that background as well. I'll show you both, but you can probably just ignore the Node.js if that's the case. There are going to be people watching this video that may actually use it. If you're using Visual Studio as well, you want to make sure you're installing the Microsoft Azure SDK for .NET. That's for Visual Studio 2015. Visual 2017's got that baked in. So it's a matter of using that. So when you think about your applications, most of the things that we're creating tend to be data-centric. So we'll need to supply data to them in some form. So there's a few questions you want to ask yourself. What kind of data is it? How is it going to be queried? How much data will you be storing? Because that might mitigate the technique or the cost. Is the data binary? Do you have replication needs? If you've got large replication needs, you might even choose something like DocumentDB. For most of us, we tend to work with SQL Server. I'm going to get a show of hands. Who's working with SQL Server? Yeah, again, most of us. So that's the one we're going to concentrate on today. So we can use SQL Server on the far left. Table storage. Table storage is good if you've got a consumer-based app. You don't know how much it's going to grow, so you can incrementally align your costs with the amount of users that you have. I find that's quite good. Document storage, using DocumentDB is quite delightful. I'm not talking about it in this session, but I would encourage you to go and check it out. For mobile developers, it has a lot of great stuff built in. The scalability is fantastic, and in addition to that, it has geographical types built in. So you can do searches based on location. You can say, I want to search for something based on my device's location and give you back those queries. And that's something you want to do with mobile devices. You want to be very location-centric. And also blob storage for unstructured data like images and other files that you may have. So typically what you do is you'd create a SQL Server database in Azure using the portal. You go through a series of steps. Obviously, we're not going to do everything as we go through it. We don't have time for that, but I just want to show some main points. You'll create a new data storage, create a new SQL Server database in the Azure portal, provide your details, provide your subscriptions. This is assuming that you've got an Azure login already. And once you've defined that, you'll need to set up a data connection. So you'll have a mobile app portal, you'll have a SQL Server created. You need to link those two together in order to use that within your mobile app. So there's a pretty easy configuration you go through. You create a new data connection within your mobile app. You add a new connection. MS_table connection string is the default name you use. You connect that to your database, and then some magic happens in regards to that connectivity between your app and device. Now, if you're using Visual Studio, a lot of that is baked into the wizards as well, and you'll get near identical behavior between the portal and also the tooling. All right. So depending on which mechanism that you use for the back end is going to depend on how you create your structure of your database within the server. So if you're using Node.js, there's a mechanism called Easy Tables where you actually just use the portal to add custom columns in, define indexes on your table. It's a very easy structure. ASP.NET allows you to create something called a table controller, and entity classes which define your structure. So like any ORM system, like the Entity Framework, or NHibernate, if you've used any of those systems, you just basically define the schema in classes, and it will store that within the database for you. Node.js is a no-code option. It's pretty easy to set up. I set the database up for this demonstration using Node.js in probably about all of 2 minutes. And that was probably with a little bit of a break in the middle, just to think about some things. So if you're using, actually I'll go and show you the Node.js system. All right. So we'll just switch over to the screen. Hopefully you can see that okay. So they have this concept called Easy Tables. And as its name implies, it's very easy to set up. So I'm in my back end. I've got a table here called Favorite Spots. And Favorite Spots really has a series of columns. You can see I've already got some data populated in there. I can manage the schema and just create a new column. And define the type. It's got some limited types, but it's pretty effective for the most part. But you are limited to those data types, and that's probably its core limitation. Just switch back to the screen. Hope it's number. Yeah, that was the Azure portal, but it runs on a Node.js backend. You don't actually have to code any JavaScript. It's just configuration. So Easy Tables is only supported on the Node.js backend. Just trying to switch over to the main projector. Nope. Sorry, the AV. Oh, what's the main projector? Yeah. Okay. So what you normally do in the .NET world, which sounds like what most of you will do here, is you'll actually go through a couple of steps. You'll create something called the data transfer object, which represents the item that you want to send to and from the server. So that's the DTO. And you also create a table controller. And the table controller basically is that endpoint that allows you to connect from your mobile application to do things like query for data, to insert, update, and delete that data as well. So the DTO is essentially just a class definition. And you inherit from another class called entity data, which is defined in the Azure SDK libraries. And you basically define the columns that you want. Those columns are defined using properties on your objects. Pretty simple step, really. So you have to inherit from entity data, and you just add custom properties. There's a few rules that you'll use with these custom properties as well, just to indicate other aspects, like maybe you want to add a property that isn't stored within the server database. In that case, you can just ignore those properties. So for example, you've got the first name and last name. You want to have a full name property, but you want to ignore that and not save that to the database. So entity data is really just a baked-in class that we can use to inherit from that has all the information about dealing with the Azure database. Azure, on the back end, provides us lots of capabilities, like the ability for offline syncing, which is very useful, especially within Australia, where we've got a lot of places that don't have good network capability. So if you inherit from entity data, you get all this goodness already baked in. Now, what will happen with your to-do item, that item will actually map over to an underlying SQL Server database. So the text and complete properties, well, they get set up as columns within the database. And all the property names are translated to the appropriate column names. You can change those as well, just to match up with maybe an existing database, or if you feel like the database or the column name doesn't actually match what it is that you're trying to do. All right, so here's another example where we can just tweak that as well using the column attribute. We can also supply an index on that, just for faster searching against that property. And if you look at the tag property here, this might be a calculated property, but you don't want this in the database. You actually want that just potentially on the server side. So yeah, also we can define the table name for the storage as well, which is very useful as well. Like this example here, I've got an app called My Favorite Spots. I spelt my favorite wrong. I spelt favorite without the U. And I thought, well, I should correct that. And then I realized, no, we can use that to demonstrate how you might actually match that up. Lots of DBAs and will have different views in spelling that I do, I think. Now, you've also got the table controller. And the table controller is something you expose from the server, like a web API endpoint. The table controller implements the OData specification. So you can use that to expose your data to query, insert, update, and delete, all those good things, but you don't have to write much code at all. In fact, if you're using Visual Studio, the wizards will actually generate the default code for you to do that. And then all you have to do is find out what the endpoint is of your server, then query against that operation. It becomes a delightfully easy process. You can also expose additional methods from there, and like a web API controller, using the prefixes or using appropriate attributes, you can define additional endpoints from that service. If you're also writing web APIs using the API controller class, you can also specify your own methods as well. And if you want to hook that into the mobile services endpoint, you would just use the mobile app controller attribute in order to do that. So that will allow you to take advantage of things like the authentication that's built into the Azure Client SDK, which we'll look at in just a minute. All right, so that's the server side. And you just go through that setup, and normally at that point, that's where we start coding the mobile client potentially. All right, so remember we've got those three parts. We've got the data, we've got the authorization, and we've also got the push notifications. And these are the kinds of services that we want to connect to the server. So far, we've just really looked at data, but the authorization notification we'll look at a little bit later as well. Now, the first thing we need to do is to add the appropriate NuGet packages into your project. So either Xamarin Forms or Xamarin iOS or Xamarin Android. So you'll add that typically into all your projects that are relevant. If you're using PCLs, you'll add them to all the libraries. If you're just using Xamarin Native on iOS or Android, just into the appropriate packages. It'll also bring in things like Newtonsoft JSON or JSON.NET, just in order to serialize and deserialize the content there too. Now, also on the platforms, iOS and Android, you don't need to do this on Windows, but you need to initialize the mobile services client in order to make sure it's all set up before you can use it. And it's just a single line of code. On Android, you'll typically put this in your main activity, and on iOS, you'd put it in your finish launching method. So normally is one of the first lines of code that you have. I typically call this before I call Xamarin Forms in it, in order to start if I'm doing Xamarin Forms, or if I'm doing a Xamarin native platform, I'll just put it right at the top. Awesome. Now, once you've got that done, that's actually most of the housekeeping for setting up the project. You just need to create your mobile service client. And when you create a service endpoint, I'll just switch over to the other screen for a second. I might just use this endpoint here. So I've got this is my node-based backend. The C# or the .NET one will be very similar. There's a URL that's associated with my service as well. So I'll just open up that service. And it'll typically show a screen there. But that URL, this is the one that you want to use in your mobile service client. And in fact, what you typically do is actually use HTTPS, because platforms like iOS expect that you will use it. And also if you're using authentication, which we'll look at a little bit later, you want to change that to HTTPS, because you'll run into issues if you don't. So I've got that particular service running. All I need to do is create that mobile service client. And that's going to connect me up to Azure, or have enough information about how I'm connecting up to Azure. And the mobile service client is very elegant. It allows you to do things very simply, so you don't have to go through that pain of writing all these different moving parts that connect to each other. So the mobile client, if you want to request data from your service, so I defined a table on my service called entries, I would connect up to the app service just using normal HTTP verbs and basic REST access code. The Azure app service would talk into the database, get the corresponding tables, return that back to the app service, and the app service would serialize that data as JSON and send that back to the mobile client. This is a very simple process. To give you an example, when I put this demo together, I probably spent about 7 hours setting up the user interface and probably about 30 minutes connecting the data in. So it's a significant ease of use that you get. And actually accessing it is a matter of using an interface called iMobile Service Table, which defines your database table endpoint on the back end. You define that connection. So here we're getting a table called diary entry. We're storing that in a table, and then we can query that table. Here we're using the read async. Normally you'd actually probably use link on that data to query and filter and only get the data that you need. But because it's strongly typed using generics, you can use IntelliSense to get access to a lot of that information. And it makes it a lot simpler as a process. Who's ever written a REST service from scratch and gone through that pain? Yeah, you know the kind of process and struggle you can go through. Now also, the Azure Mobile Client, the entity objects that you deal with also have some properties that are exposed from that server as well, baked in. So things like the ID, which is the primary key for each of those records against that table. There's things like the Azure version, which is the version of the record, the created on, which represents when that record was created, and the updated date, which represents when it was last updated. There's also another column in there representing soft delete. So you can facilitate the ability to track when records are deleted, not delete them on the server, but actually just mark them as deleted instead. And that's really good for enterprise auditing. It's also good for offline syncing, which is another great feature of Azure Mobile Services. So the first thing we need to do, we need to get access to the table. We've got our data transfer object in the form of the diary entry here. We're sending the request to the service, and if we wanted to get some data, we'd hit that particular endpoint. We'd just send a HTTP GET to that location. Likewise, if we wanted to insert, update, or delete an entry, it's very elegant. You just have a matching insert, a matching update, a matching delete. That's pretty simple. All right, now to retrieve data, it's just as elegant as well. So you'd have a query against the data. So here we're using the read async and also the lookup async. So we might retrieve all records here using the read async or retrieve a single record using the lookup async mechanism. And based on a particular identifier that you might use. So often you might need to just get an identifier for one record, use this on another table to look up another client. Typically you'd actually use over there for a second. Typically you'd use link and filter that query directly. That's what I tend to do. So I've set up this application here. Let me just make sure that the screen is projecting so you can see what it's like. Awesome. So I've got this application here called My Favorite Spots, which really just represents some data that I'm storing in Azure, which is just storing all the various locations that I quite like. And all this information is just being stored using this table mechanism. So I'm going to show you how I hook this up. Now, first off, when I created this project, I actually created a mock interface that I wanted to work against called iSpots Data Service. And I find this is a really nice way to work. You basically define the abstraction, you create a mock implementation so you can test the user interface, and when you've got the user interface working, then you add the data layer in. But here I've just got a couple of methods. Search for a particular location. I've got some search text. I've got some latitude and a longitude, and I'm pasting in. And if the particular implementation is going to support latitude and longitude, it'll use that. Otherwise, it won't. And also the ability to save that particular spot. If I've got enough information to send to the service, it'll save an entry there too. Now, I've also got this class here as well, the Azure SQL Server Spots Data Service. And this is using the Azure Mobile Service Client. So there's a few things that are going on. I've got a mobile service client being created. That's actually being created by my app. So you can see here the client is being created. I'm passing the URL of my service. In this case, this is the Node.js version of my service. And then if I just go back to the SQL Spot service, we'll be able to see that in action. So here, I've got a method here, initialize, which is really just getting a reference to the table. So I might even have some logic there. I'll just return out of that. I only want to initialize that once. And then I've got my favorite spots table reference, and I can use this favorite spots table to reference my remote data. And those two methods I've got, well, the save favorite spot async, really just make sure that all the table is set up. And if I have an existing ID, which means I've inserted an entry into the database, I'll just update it. Or actually, no, if I don't have an existing ID, I'll insert it. If I do have one, then I'll update that record there directly. And then just return out of that function. And likewise, these are all asynchronous operations too, which is really important because we don't know how long a network operation is going to take. It's obviously going to take longer on a 3G network versus a 4G network versus Wi-Fi. We need to await those operations. And likewise for the search operator, I've got my items. I'm just doing a couple of simple queries. If I've got no text, then I'll just get the data from that table directly. That's going to return everything. Of course, you can use link and just get a page of data if you want. I'm just using this as an example. In this case, if I have a search term, just move that to the next line, then I'll use that particular search term and then get the list of results coming back from that. And all my items that are coming back, I'll just return that data back to a list. I'm doing some mapping there, but I may not actually need to directly. But by running that, then I get that effect of being able to use that service. So this is my search result. If I do a search for beach, for example, this is actually going off to Azure, hitting those particular services and bringing back all the records that have the term beach within it. Interestingly enough, that delay, most of that delay is actually not hitting Azure. Most of that delay is actually trying to get my current location using the GPS in order to send it up there. The Azure part is actually pretty quick. But here's all the entries that have the word beach. It's all broad beach though. And if I wanted to add a new entry, I could take a photo like this, say cheese. Cool, use that photo. It will process the image here. I'm actually just doing some data processing here using cognitive services. So you can see it's actually worked out what it is that I've taken a picture of, a group of people in a room, and uploaded that to the blob storage as well. So it's pretty nice from that perspective. But I'll just put on that here, my favorite people. Let's put that in. And just save that entry. And that's going to hit the remote service. But it's just using those two methods from the Azure mobile client. And that's simple code to look at. Like it's not complex at all. And I think that's one of the beauties of it. It's very elegant and simple to write. And now if I do a search, I should actually see that smiling picture down the bottom with everyone. Cool. Just bringing that data back from Azure. It's a very simple process to use. Right, just switch back. Oh, cool. So that's the mobile client connectivity. It's a very simple process. Now, if you are using Link, there are plenty of operations that you can use. Who's using Link in their .NET development now? Yeah, great to see. One of the things you'll find with Link is most of the operations work as you would expect. Some subtle things, like if you're using the select operator, you can only apply the select operators to columns that exist in your DTO. So just be careful of that. That's probably the only gotcha to work with. But essentially what will happen is because it's using the OData spec, when you send those link queries to the server, it'll translate it into a filter string like you can see down the bottom. So it's very efficient. There's not much processing happening on the client side. It tries to do as much as it can by pushing it to the server and minimizing that network traffic and minimizing the processing that you need to do. Awesome. So you'll also need to call an appropriate method at the end of your link as well. So the link will define what you want to select, but you'll need to use a method like toEnumerable async, toCollection async, or toList async to actually execute the data against Azure and bring that back. So just be aware of that. Now, another great thing that Azure offers is the ability to have offline data synchronization. And it's just a few lines of code. I've got an alternative implementation of that service running on the device as well. But having an offline sync is important for a number of reasons. Often we don't know when we're going to lose mobile connectivity. We're always going to lose network connectivity at some point with a mobile app. We can't escape it. A network might go down. We might be on the train going into work, going through a tunnel. We might be in a rural area. We might actually be in a hospital where they've got a radiology department and lead-lined floors. Like for a variety of reasons, we're going to lose connectivity. It just comes with the territory of a mobile app. So having an offline cache allows you to store that information locally on your device, and when you have a network, push those changes to the network. And that makes a lot more sense. It also makes it faster because you're working with local data instead of remote data. It's pretty quick to write that locally and then push it in the background. So you can get some speedier access then, and you do get to control it as well. Now, to add that into your mobile client app, you will need to add another NuGet package in there, Microsoft Azure Mobile Client SQL Store. And you'll need to do a little bit of setup in order for that to happen. So you'll need to create the store itself, and you'll also need to initialize that with your mobile client. So just a few lines of code will set up the store. So here we've got a local store.db. We only supply the file name. The Azure mobile client, the actual mobile service SQLite store knows where to store it per platform. So if you're using iOS has particular rules about where you store things. If you store things in the documents folder, that has to be for user-generated content. It's the library folder that needs to be for app-generated content. So iOS will put it in the right place. It'll define the table within the local SQLite database. SQLite is used by default. You can also customize this and extend it and use your own storage mechanism if you choose. And then we initialize that data store as well and provide a sync handler. And the sync handler essentially coordinates the activities between what you do against the data and how it stores it locally and how it's eventually going to push it to the server and synchronize that data back and forth. So you don't have to do that painful work of writing synchronizing code between a client and a server. This is a much easier process. So when you are working with the client, essentially what you'll need to do is create a mobile service client like we've been doing before, but instead of using the normal table type, we use an iMobile service sync table. And that actually has the same methods that are on the normal table interface, the insert, update, delete, and query, and link support as well. So often, after you've done that, it's just a matter of using the same or very similar code. The one difference is that because you're writing now to a local cache of the database, you will need to coordinate with the server, tell it when you've got updates to push to the server and when you've got updates to pull back. So there's two methods here, push async, and there's also pull async. Push async basically says all these changes locally, just push them to the server and update those. And there's also pull async, which will basically pull down changes from other people. So you might have downloaded a record, someone else has downloaded that record as well, but that person has also deleted one of the records that you've downloaded previously. So you'll get those updates as part of that notification. It manages that process for you. And with that, the push async will also do a pull async. So in this particular regard, the pull async is actually unnecessary, but you may want to control that. In addition to that, there's also conflict resolution. So if you've got situations where two people are trying to update the same record, what can you do? There are mechanics built into it in order to say, okay, if I'm trying to update a record that someone else has updated as well, what are the operations? What am I going to do? What are my business rules? And you get to control that aspect. You'll get an error noting that particular error conflict, and you can get to choose, well, you know what, last update wins, or let's have a look at the data, let's try and merge it. You'll get that data back, you'll make the appropriate decision, and then you'll save those changes back to Azure. So here's an example where we might actually resolve a conflict. And we might basically say, let's have a look at the objects. So we get not only the object we're trying to synchronize, but also the object on the server. And we can compare those. We can make some appropriate decisions. And it might be that the change makes no difference. So we just say, let's actually cancel the changes that we've made, or let's actually update our local version and save that to the server, for example. Cool. So I just want to get a quick show of hands. How many people are writing apps now? Yeah? How many people are writing consumer apps? And how many are writing enterprise apps with Active Directory and the like? No, mostly consumer apps? Okay, interesting. Cool. So the mobile services has authentication support built in. So it will use OAuth in order to authorize against those services. And when you do this, there are typically three parties to this. There's your client application, there's the identity provider, and then there's Azure in the middle. So we coordinate our authentication through Azure. And Azure supports a lot of the social authentication mechanisms that most of us are used to, things like Facebook, Twitter, Microsoft, and Google Plus as well. So we can basically configure the access to use these as a trusted authorization provider and use that as part of our application process. And again, it's a very elegant process. I think it's actually much more a situation where you have to code, and not necessarily code. It's more a situation where you have to configure how that Facebook authentication is set up. For example, in the app that I've got here, we'll turn on authorization, so you can see that in just a second. And what will happen is that you'll need to log into a service, but in order to do that, you'll need to create a new app in a service like Facebook, configure that with your Azure endpoint. And there's a series of steps that you go through, but the Azure portal actually does a great job of explaining the various steps that you need to go through in order to do this. I'll just go back to that previous slide. Now you can also use Azure Active Directory in order to support enterprise authorization. And it's actually a very similar process to the other social authorization points. There's just some checks that you go through to make sure everything's set up and provide information. So some basic rules of thumb is if you need enterprise authorization, you'll tend to use Azure Active Directory. If you want to use a social authorization provider, use that specific social provider. If you want to support multiple providers, you'll use a service like Auth0 or Identity Service. Or if you want to set up your own custom username or passwords, you'll tend to use Active Directory B2C. And I believe there's a couple of talks here at Ignite on B2C as well, so it's a good idea to get along to those if you're interested in that space. Another interesting thing about the work that you do with Azure Mobile Services is when you create a table, by default, they're public. So most of us write apps that need a level of security. So you'll need to configure that directly. So you can force security on your tables. You can force it on a particular operation, for example. I can say, well, I'm going to let everyone insert records, but only a few people insert or update or delete. I might say that no one's allowed to delete. Or you can have some custom rules against that as well. It's actually more configurable if you use the .NET mechanism to do that. But it is quite a good mechanism. So for authorization, what you would tend to do is you need to go into the portal and actually say that your app requires authorization in order to work. So it's just a matter of configuration on that application setting. And when someone's not authorized, you can tell them what to do as an action there. You might say, okay, if they're not authorized, let's force them to log in via Facebook. So you can get that level of security. Now there's also a number of providers as well. We've talked about this before. And each of those providers require their own custom configuration. If I'm working with Facebook, Facebook's going to expect a particular list of information, particular API keys. It'll also expect me to provide scopes, and scopes are really things like the rules about what I'm asking Facebook for example. Am I just asking for profile information? Am I asking for a friends list as well? Am I asking for access to photos and so on? And each of the providers will have their own. And for example, Twitter will require these two things here, the API key and also the API secret. But if you look at that section here with the red rectangle, if you click on that section in the authorization, the portal team have actually done a really great job of describing that process of how to set up each provider. So you don't have to remember all those details. Click on that little icon, it'll actually go over to the appropriate setting and set that up for you. So there's a few of those providers like LinkedIn and Twitter that don't set up that much. So I often have to go back and remember. In addition to that, on your mobile app service, there's also endpoints that are exposed. And those endpoints are exposed, and you'll not often, but you will need to provide that information to those identity providers on how to configure it. So once I log into Facebook, how do I call back into my app to let it know, here's the details. Awesome. So there's also another thing that you need to add in, which is the token store. And by default, the token store is enabled, just down the bottom here. Well, you can't actually see that. But if by any accident you've turned it off, just check that, because if you have that off, the authorization won't work on your mobile clients. Just for those people that get caught debugging. And also, once you've set up the system as well, you've got all the configuration done for your identity provider, you can actually put in the URLs site/.auth/login/ and then your identity provider and actually test that it works. You don't even have to write code to do that. It'll actually prompt you and ask you, this application would like access to the following information. You log in with username and password, presents that information about what particular scopes that particular identity provider is requesting, and that'll take you back to that callback URL. And from there, that's a good test that everything's working and authorized. And there's various points for each of the providers. Cool. Now, I mentioned this before, so you can actually configure the rules for each particular access as well. So if a request has been sent to the server, you can actually say what to do in the event that they're not authorized. All right, now if you're writing a table controller, you can actually add additional attributes to the service as well in order to add security. Now the authorize attribute, a lot of you are probably used to that from ASP.NET MVC. Is anyone used to that? Yeah, I can see a few people nodding. And it's a similar process here. So you just basically add the authorize attribute to either the diary controller class itself or individual methods to require security for that particular approach. And it's a pretty easy and elegant way to do that. Likewise, if you want to apply the authorize attribute to an entire class, it might be just one or two methods that you want to allow anonymous access to. So you can use the allow anonymous attribute and then specify that people can get access to that point. So it might be that people can insert, update, and delete, but you might have some public information from that same data store that you're okay with other people having. Now on the Node.js side, security is normally done in one of two ways. One, you can use the portal and just basically set up the authentication rules for that particular provider. You might say, okay, they require authorized access, for example, to insert, update, or delete. Or you'd actually go in and actually script some Node.js code to restrict the security. You might check the attributes of that user or whatever business rules are applicable in that situation for you. Cool. Now there's also a new mechanism in the OAuth workflow that's actually pretty important. There's client flow and server flow. I'm going to demonstrate server flow for you, but client flow is really when you authorize, instead of having a web page come up, which happens with server flow, and you authenticate and move on to the next step, client flow basically brings up the client application on your device. So it'll bring up the Facebook application and you authenticate through that. And that's actually much more secure. People trust that, and it's also a lot quicker too when you're going through that process. But if you're using particular services like Facebook and Google require client flow after, I think in a few months' time, they're going to basically say that you have to go through client flow in order to authenticate against their services. So it's pretty important that you know how to set that up. Yeah, normally I think the default is that it'll go over to the web page. Yeah, so it's kind of okay as a fallback there. Yeah, but you can still use the web access for Facebook. You'll see that in a second when we bring up the demo. All right, but to log in, just once you've configured it on the server side, it's a matter of calling the login method and providing the provider of choice. So in this case here, this code is using Twitter, but we could supply Facebook to go through the same process. Also, there's some subtle differences if you're using iOS versus Android. The login method will require parameters that are specific to that platform. So here, this is in a shared project. However, if you're using portable class libraries, you can still achieve the same thing. You just need to define an abstraction with it instead, and that will work. So for Android, you'll need the main activity. So the forms context is the main activity there. And in iOS, you'll need access to the UI application, shared application, key window, root view controller. All right. So the client flow is a little bit different. So typically you need to refer directly to that particular client's API. So Facebook has one, Google has one, there's Active Directory has one as well. And those are pretty popular options. Not all providers have a client authentication mechanism to use. For example, Twitter, I don't believe, has one. But you'll essentially go through that process. You'll look at the documentation for that particular platform. There's some links on a GitHub repository I'll make available after this that define where to get those particular locations and NuGet packages. There's also a table in a couple of slides as well that'll show you too. But essentially, once you authenticate using that client tool, you'll get an access token back and you'll just populate the mobile services client user details with that token, and then you can continue on as if you'd authenticated through the server flow method anyway. All right, so once you do authenticate using the login async method, you will get that mobile service user back, and that'll give you some details about the user, the current user. They'll have a token associated with them, and you can use that for storage as well. So if I'm sending some information to the server, I can use that ID to say, well, here's the server, here's the user that created that new spot for me within the system. So here's a couple of wrappers that you'll need to be aware of as well. If you're authenticating to a server, a really great user experience is that if you come back and use the app again, is that you don't need to log in again. You shouldn't have to log in every time. A lot of people will get frustrated with that, especially for consumer-based applications. So if you are storing the user token information on the device, ideally you should be using a component like Xamarin Auth or Samir ITA Apps plugin secure storage. And that'll allow you to store to the secure parts of the mobile device, or at the very least encrypt that information locally. So if your device is compromised, you don't lose access to the tokens. And it's not going to cause too much grief. So let's have a look at the social authentication. So I'm just going to switch back here to the application. I've commented this out just for the time being. And to provide authorization, I've got a simple class here called auth storage that I've created. And auth storage is actually using that cross-secure storage, which was the second of those two options that basically allow me to store key value pairs in a secure manner on the device. So I'm just trying to see if they're logged in, and if they are logged in, I'll basically load the details from that local store, and once they have logged in, I'll save those details to the local store as well. So in my authorization section, my logic is now, well, if you've logged in, load the saved user information and then go to the main page of the application. Otherwise, we'll just go to the sign-in page, and you can do the normal workflow in order to authenticate. Now I'm going to demonstrate this on my simulator here. One of the things you'll find with working with mobile capabilities is certain things like secure storage and push notifications won't work on the simulator. And because the secure storage is not working on the simulator, it'll force me to log in every time, so you'll be able to see this. If I run this on the device again, it'll be a little bit different, and I won't actually be able to show you the authentication. But here's the My Favorite Spots app. So this is the screen that you haven't seen. So I'll click on the Facebook sign-in, and that'll bring up the authentication for that. I've already authenticated for that particular application, so it's actually approving me for that. I might actually just stop that for a second. There we are. I'll delete the app and redeploy, just so you see the new application start again. So that'll deploy the app, and this time that secure storage hopefully will be gone. I'm going to allow some of these things. So here's the authentication. Should ask me to log in again, so I'll just provide my details off the screen. Let's see how that goes. Hopefully I've remembered the right password. Cool. And that's authenticated and sent me through. And then I've got access to that information there as well. So that authentication was very simple. And in addition to that, I'll actually just go back to the data storage for just a second. So this is my data storage. I've got easy tables. I've actually got two tables that are actually identical. But the first one, favorite spots, doesn't require authentication to use, but the second one does. So this one's got the data in it. The second one, favorite spot secured, that's only got the one record. But the permissions for this particular table, let's have a look at this. So I can change the permissions there. You can see I can insert only if I'm authenticated. I can't update, I can't delete, and anyone can read though, but no one can undelete as well. So I've got some basic lockdown. And you could do the same thing in the .NET mechanism as well, just by applying those attributes. You might say, well, in your table controller, you wouldn't actually expose the ability to delete or to update. And for insert, you'd apply the authorized attribute in order to make that work. So it's a much easier way of working. I'll just do a quick pull to refresh. That's trying to get my local notification. Oh, that app's actually still hitting the old service. But essentially pulling that data down nonetheless. Cool. So that's the basics of social authentication. And you can see there's actually not that much code involved in setting this up. I always feel a bit awkward presenting things that are really easy to use, because you want to get value from these presentations too. But sometimes it's just awareness of these features that are really great. Now, there's also a bunch of other features that are really useful in Azure as well. So we'll just finish off with this section. So push notifications are very common to set up. In order to do that, I would recommend using the Push Notifications Hub that's within Azure. It's a very elegant way to do this. I was talking right at the start about some of the projects I'd worked on where setting up the REST services and setting up the authentication was difficult. I'd also done in the past some fairly large push notification projects, a couple of them actually for that matter. And in order to do that, I was using services like PushSharp, which was a C# open source library that was difficult to manage, mainly because there was just one person maintaining it, and there was all these changes coming in from some of the providers like Apple about their push notification specs. So I never really quite trusted a lot of the providers as well. But on the Azure side, it's actually very elegant how you can communicate up with that. So you would typically use the push notifications hub, create a new hub, provide some details, and then you configure the hub for your various platforms. So if you're using iOS, for example, you would go in, create new certificates on the iOS portal, go through all the configuration steps. Just like the authorization provisioning, you'd actually do the same thing for the push notifications. There's great documentation on each of the providers. So most people tend to do the Apple and the Google provider and the Windows providers. You can also use Amazon if you're marketing to the US. There's a lot of people with Kindle devices, for example. You can push out to those. It's a very easy configuration, and it sets up this hub connectivity. So you'll subscribe from your mobile client. You'll say, I want to subscribe from this device. This is my device ID. These are the particular tags that I'm interested in. Those tags could be a general category, or they could be a tag that represents that device only. And then from the server side, you'll just send a push notification to a particular tag group with a corresponding message. So you might be doing a broadcast to a larger group of people, or you might be doing a very targeted approach just to one person. It's pretty easy to set up. On the client side, though, you will need to use a couple of components. There's the Azure messaging you'll find in the component store for the Xamarin store. You'll add that component in. There's code samples within that component when you download it that'll show you what you need to do to set up. So on the iOS side, it's more about configuring your UI application delegate subclass to provide the appropriate callbacks. And on Android, you need to set up a new service that receives those notifications and then informs your application that you've received a notification. On the Google side as well, you will need the Google Play Services cloud messaging. And even more recently, only over the last few days, the Xamarin team have updated the docs to provide some information about the Firebase messaging from Google, which is the replacement of GCM. Cool. Now, another pattern that you'll often see with Azure services from the mobile client is basically a brokerage pattern. So often you'll probably want to hit services directly. However, normally those services will require access tokens of some kind in order to securely access them. So the application that I've built for this demonstration today, or this talk today, is all public for the most part. So I can upload information to my blob storage, for example, of that picture, and I can write data to my database. But some of the services like DocumentDB, like the blob storage, require particular tokens. So often what you'll do is you'll add a new API container or API controller to your service, and you'll actually call that to provide access to particular resources within Azure and give that token back to the mobile client. And then the mobile client can talk to that particular service like DocumentDB, like the blob storage, and provide that token in order to have secure access. And that might be timed access, for example, just to limit the security options for that. So it's one of the options that you'll see there. I just wanted to go back and demonstrate some of these capabilities. I know we're running a little bit short of time. I think we've got about 7 minutes to go. But if you've got push notifications enabled, and push notifications is one of those features that you can really only do on a device. You can't do it on a simulator at all. So I've got my device running here. When I ran the application, if I look at the source code, so the push notifications is really a native feature. It's not something you would do with Xamarin Forms. But in the app delegate for iOS, I've got some configuration about my connection string to my notification hub. I've got a single method in here called set up push notifications, and it's basically saying these are the kinds of notifications I'm interested in receiving, so alerts, badges, and using the default sound. I'm registering for push notifications, and then I'm also processing the notifications as well, because the application may be started as a result of receiving a push notification. So that options parameter that you get, you might have to forward that into the same mechanism that you use for processing them. And once you've registered for push notifications, that's where Apple's actually said, here's the device token that represents this unique device. It'll send that to your system. You'll actually receive that details, and that's where you'll use the notification hub from Azure and send those details to the service to register that device there. So this is housekeeping code, really. If you're using the Azure messaging component, all of this stuff is in the documentation. You can essentially copy and paste that in there and have that working fairly easily. So where I'm processing the message, I'm just getting those details here and sending that back. That's from the app. But if I switch over to the app now, well, there's the app running. In my notification hub, I can actually do a test send. So I can select which device I want to send to. So this is going to be the Apple platform. And I can send a message. Let me send that. I'll bring up the reflector. And you can see the push notification come through. It's a very easy mechanism. And normally you'd send that through from the server component. The server component just basically says, here's the connection string details for the notification hub I'm using. What's the tag? What's the message? What's the platform? So that's one of the other services. The other thing I'd like to mention is the use of the Azure Storage Explorer. So often you'll have a need to store images and other artifacts within Azure. So one of the things you don't want to deal with is a local file system. So it's better to deal with a storage mechanism because that gives you the ability to scale out. So you don't really want to have to deal with hardware capacity. So here I've got a storage account against my Azure service as well. I've got a blob container that I'm running. I've actually exposed that as a public blob container, so that way the images can be retrieved as URLs after I upload them, and that's what I'm using in my mobile client app. I'm just downloading a particular image and then presenting that in the app. But I've got all those images there, and the Storage Explorer is a good tool to use just so you can copy files in, so you can move files out, you can see what's happening, you can debug the process as well, and that's available for Mac. And also, if you're using Windows, you're better off using the Visual Studio integration in order to see that information. But just something to be aware of. But actually storing that, again, it's very elegant as well. So going into the Add Edit Spot page, this is the code that's actually doing the saving to the database. So whenever I'm saving a spot, I've got some code here to connect to Azure and actually provide that information. So I'm creating the cloud storage account, I'm creating the blob client, and there's a folder that I want to put everything in. If that folder doesn't exist, I'll create it, and then I'll upload that blob directly into the file. And because it's in a specific location, and I can get this location from the Storage Explorer tool, then I know how to expose that as a web address and use that in my mobile client as well, which is pretty nice. So once I've got my spot there, once I've uploaded the image, I'll have a URL, I can put that in my data, save that data to the normal Azure storage mechanism. Cool. Now, I think the last thing that's worth mentioning is it's just the cognitive services. Has anyone seen cognitive services before? Just a couple? There's a lot of great things that it can do for you. I'll just give you a bit of background. About 4 or 5 years ago, I worked on a system that was doing invoice scanning of documents, and we had a team of about 5 people work on that round the clock in order to get that working. When Azure Cognitive Services came in, a lot of that stuff we could have done with that API with one person. There's lots of capabilities that it has to analyze information and provide good levels of information, whether that's semantic information, where it's vision information, text-to-speech, video analysis. It's a really good way of looking into the system. So in my display spots page, where we take a photo, I'm actually calling into the Vision Services client. So this code, normally if I'm doing work with a service, I'm using wait, but I'm trying to do things in parallel here because I'm getting information from the geolocator to reverse geocode the address to get the address from the current latitude, longitude. I'm also hitting cognitive services to basically say, here's the image that I just took. What is it describing? And I'm also basically asking for the location as well. So in this case here, I'm getting my services. I'm asking it to describe an image. I'm getting the result back. And in that particular case, this is all the categories, so all those tags that represent the image. And I'm also getting a series of descriptions that describe what it is I'm taking the photo of and returning that to the system as well. So in that particular case, I could select an image from my screen, for example. I could select the go-karting image. It would send that up to the server, and it should be able to describe what it is that I'm looking at. A group of people riding motorcycles on a track. Pretty close, but it saves you a lot of that semantic analysis. And there's a range of other services there as well. Cool. So to wrap up, basically, the fundamental thing that Azure Mobile Services gives you, I think, is time. You don't have to go through that process of heavily writing a server REST end, of setting up infrastructure to do authentication, to set up infrastructure for push notifications. It's all there. It's all been heavily trusted and maintained like all the other Azure services. And the cognitive services is an amazing flavoring into the other capabilities that we have as mobile developers. And the demo that you saw today, probably a day at most that I've spent on that, working on it to bring that in. And most of that was user interface and the way I wanted that information to flow. The actual back end took probably the least amount of time using Azure. So it gives you this richness of capability that you can just leverage. I encourage you to check it out as well. I'd also want to mention we've got the Visual Studio booth down in the Microsoft room. Go and have a chat with them. If you've got an MSDN license, you may not be aware that you've already got Azure credits against your account as well that you can use. So check it out and see what you can take advantage of already. Awesome. So with that, make sure you please fill in the evaluations for Spark After Dark. Get your pilot's license if you can. Hopefully some of you have got some of those already. And also remember to collect your wristbands for tonight's event as well, because it sounds like a lot of fun. Who's going to play pinball? Video arcades. I'm going to as well. Cool. And also, if you have any other questions, I'll be in the speaker lounge answering questions. You can also follow me on Glenn T. Stevens. I'll post some additional links to GitHub as well after the session that you can look at and download some additional resources if you're interested. But yeah, I'll be around for the rest of the conference. Please come and chat, say hello. But we do have questions, so if anyone has some questions. Yeah, you do need to worry about refresh tokens on those providers that require it. So things like Twitter don't require it. But the APIs are fairly simple. If you're using something like Google, you have to authenticate with additional information to indicate you want refresh tokens, and then you just need to go through a process around that as well. Some of the links I've got describe that process for you. Yeah, just for some of the providers. That's one of the interesting things with authorization is that each provider will do their own thing in regards to there's no consistency around scope names or other capabilities. So you have to dig into that a little bit to get exactly what you want. Cool. Any other questions? A little too soon after lunch, was it? Yeah, all right. I'm feeling it. Cool. Thanks, everyone.